going to go ahead and open up SOLIDWORKS here. And I will just open up our main assembly that you saw. Just go over that again real quick before I jump into the modeling. So we have an assembly here, woodworking device assembly, and by the time we're done today, we're going to have all these parts pretty much as you see them now in a working assembly. You can see I can move this, the handle moves similar to how the actual movement of the vise would be. We're going to create all this. I'm going to show you how to create those mates to get everything to span and work as you would expect it to. All right. So I'm going to hit R on my keyboard to bring up the last part where we left off in the last session. We're going to finish this up real quick, and then I'm just going to step through a couple of the other parts just to show you how they were made, because we won't be teaching anything new with those. So just to finish up our last session, we're going to go ahead and start this rib feature right here. And we want to create a rib feature that goes from the edge of this boss to the edge of this boss here on the different plane. And to create that, I'm going to first insert a reference plane, which you can do from Insert Reference Geometry. When I click on plane, it brings up a series of references for me to start to select. I'm going to use this top edge for a parallel selection right here. And then I'm going to go into my little view menu here, hide show items, and I'm going to toggle temporary or view temporary axes. And what that does is you can see that it brings up axes for all these cylindrical and even radial profiles in the model. And I'm going to use that axis for that boss right there as my second reference to make that coincident to putting the plane directly in the center of that boss and parallel to that face. You can see everything's fully defined up here. So I'm going to click OK. And now I have a new plane to create a sketch on. So I'm going to go ahead and just uncheck temporary axes, so I don't need them anymore. I'm going to click on the plane to start a sketch, and I will view it normally. So straight onto the screen there. So to select my geometry, my boss is kind of hidden underneath this feature right here. So I'm going to change the view from shaded with edges to hidden lines visible. Now you can see the hidden lines that are beyond that geometry that was occluding that before. So I can stay normal. I'm going to use mouse gestures by holding down the right mouse button and swiping. And I'm going to start my line right at the edge of that boss. And I'm going to go all the way over here. And I can even hold down my mouse wheel and just double check to make sure that's the geometry I wanted to select. It is. I'm still within my line command before I make that second click. I can even do a previous view without making a click and then make my final selection. And there you can see I've got that line just how I was looking. Now, just to make things easier to see, I'll go ahead and switch back to hidden lines visible. And I don't even need to see this plane anymore. So to keep things nice and clean, I'm just going to right click on it and choose hide. You can see the icon changes, so I know it's hidden there. All right, now I've got the sketch I need to create my rib feature without even exiting the sketch. I can go directly into the features, rib command, and you can see that SOLIDWORKS wants to preview it for me there. The arrow is the direction of the extrusion. In this case, I want to go towards the material. And what this is going to do is create this feature this wide, extending that direction parallel to the sketch, perpendicular to the sketch, into whatever material it runs into next. So it's basically going to fill in all this material here. So I'm going to change a few of the dimensions. We're going to make this an 1/8 inch wide altogether. And I actually want to give it a draft. So I'm going to draft this 3 degrees. I'm going to ensure the draft outward option is checked. That means it gets wider as it goes away from the sketch and as it hits the body of the rest of my part here. So I'll just click OK. And there we go. We have a nice new rib feature there connecting this guy and this boss. And that was a pretty quick way to do it with only one little sketch there. So that's a rib feature for you. We're going to continue moving on. Just going to go ahead and create a quick hole here using the hole wizard again. This is the second time we've used the hole wizard. Hole wizard, simple to do. Sometimes you get little reference area issues there, but doesn't mean we can't create this hole. I'm going to do a straight tap hole right here. ANSI inch. It's going to be quarter-20 size, and basically going to use everything else here that's defaults. Go to the positions tab, select the face where I want to position the hole, and then I can use inferencing to snap to the center and create an instance. I'll go ahead and click OK. And you can see that the hole's created. Didn't do all the way through, so let's just go back and edit. And we're going to go ahead and change, I think, the diameter of this. Let's change it to be a little bit larger. And we're going to say through all for the in condition. And there you have it. Nice threaded hole. Now these threads you see in here, they're just to indicate that there is a thread feature attached to this hole. They're not actually modeled. So these are called cosmetic threads. And if you want to toggle the visibility of those, you can go first to options, document properties. This is a document setting. And within detailing, you can have shaded cosmetic threads, checked or unchecked. If I unchecked it, go back, you can see that that disappears. I'll go back and recheck it. And then I believe there is also a setting within your view menu here that might toggle the visibility of those threads as well. So if you're trying to get that to show up in your own models, just look at those two places and I think you'll be able to find them. All right, so moving on. Next thing I want to do is shave down this extra material right here to blend into this face nice and smooth. So creating a compound curve there. So I already have a top plane here, which resides in the center of these holes, which is exactly where I want my plane. So I'll just use that and sketch on the top plane. So click it, select sketch to create a new sketch. I'll view this normally. And again, just using the line command, and start with inferencing here, move away a little bit, just because I want to ensure this sketch cuts away all the material. I can go a little bit outside of the profile of my model. Then I'm going to go to the next spot that I need to click, move away, and then move back to the end of the line, and it automatically starts the tangent arc tool. And I am going to make my next click right there at that intersection. So while I'm looking at this normally, it makes that selection possible. I'm going to click again, come away, and then just use inferencing to finish up my profile. You know, I have a closed profile once I have a shaded area there. And just for good measure, we'll go ahead and fully define this sketch by adding a few dimensions. Just going to have this stick out about 1/8 of an inch from the edge of the part. All right. Now when I rotate away from normal, you can see that my profile looks exactly how I planned, and I'm going to use this to cut away that material. Okay, so again, without exiting the sketch, let's go in and use the revolved cut option. So select revolved cut. It already knows the sketch that it wants to use. I just need to pick an axis of revolution. Again, if I go in and toggle view temporary axes, I can use this axis right here, which is the center point for that whole arc to sweep across. I'll select it, and you can see that it's giving me a preview of a 360-degree cut. I do not want to do that. I only want to cut away a little bit of the material. So I'm going to go ahead and make it a mid-plane, meaning it goes the defined degrees here away both sides of the sketch. So you can see now that I entered 90 degrees, we have 45 degrees on one side of the sketch, another 45 degrees on the other, using the mid-plane option. If I were to do blind, it would change that to all on one side of the sketch. So this seems to encompass all of the geometry I'm trying to modify. So I will click OK, and you can see that the cut was created. Go ahead and unclick temporary axes. And now we have a nice smooth transition there. Okay. And I just want to illustrate that there's always more than one way to do something in SOLIDWORKS. So if I delete that cut we just created, keep the sketch, we'll still want to use that. And now let's try to do a swept cut. Okay. So it's got the sketch profile pre-selected there for me, and now it wants me to pick a path to sweep along. Well, this path right here on this edge gives me pretty much the same result as I wanted to with the other option. If I click bidirectional, it'll continue along that selected edge along the bottom as well. And if I click OK, you can see that I get the same result. So just an example of how you can easily create the same feature using different things. All right, so let's continue on. I'm going to go ahead and make all this geometry over here mirror over here, so I don't have to recreate it all over again. So I went up and you selected the mirror option here. First thing you want to do is pick a plane to mirror about. And since I have my right plane centered in the middle, I'll just use that. And now I just want to pick features to mirror. Now you can click in the graphics area or in the feature flyout to pick those features. I prefer the feature flyout just to make sure that I don't accidentally miss something in the graphical selections. So here I know I want to mirror that feature, that dot boss extrude there. Go ahead and this next boss extrude. Don't need to mirror that cut actually, so I can keep that out. Not that one, not that one either. Don't need my plane mirrored, but I do want my rib mirrored. I want the hole mirrored as well. And I also want that cut mirrored. I got a pretty good looking preview over there, so I'll click OK to see how everything works. And there we have it. Pretty quick to get that done. So let's go ahead and finish this up by applying some fillets. For geometry this complicated, sometimes you're going to have to create more than one fillet feature. It's good practice to create your fillets and chamfers towards the end of your model, if possible. If they're part of the geometry of your model as you're creating it, and it's okay to have them anywhere in the feature tree. It just, if at all avoidable, try to leave them last. It's good practice. So you can have this option down here checked if you want for a little bit of help, and you can just start selecting the edges or faces you'd like to fillet. If I select that face, you can see all the connecting edges want to fillet. This is too large, so I'm going to drop that down to 0.05. And then I am just going to continue selecting different options. Faces to carry those fillets. I'm going to select edges here. And you can see that as long as you pretty much have a preview that your fillet is going to be successful. And after a little bit, once I start selecting other geometry, you'll see that the preview no longer wants to work. So I can just select that face again to deselect it. Now I'm in a good shape here again. So I think I'll add the same fillet here to the back edge. And it looks like I'm not getting any errors, these little guys. And once we get this part complete, we'll go ahead and start assembling everything. So I click OK, and I created that first round of fillets. Now I can go in and, even using the same size fillet, just click that face. See, it only wants me to do certain size fillets. If I go in and again make this a little bit smaller, you can see now that it'll let me select additional geometry. That's all I want to do. But you guys can see how stacking your fillets can eventually get you where you need to go. So this is basically what we're going to end up with. I'm going to go ahead and switch over to the finished version of that part. If I click on this in the assembly, I can do open in its own window. There we are. So that's the finished version, and looks like we had to create a little cutout there for the dog. I'll just show you real quick how that was done. You can see that I just created a sketch on that top face, spaced it from the edges, and then did a blind extrude cut to create that pocket. All right, so there's that part. Let's go ahead and start creating an assembly. All right, so you can create assembly in a few different ways. The most straightforward way is to go the new icon, new document, and just double click the assembly icon to start a new assembly. Well, since I already have this part open and I want it to be the first part in this next assembly I'm creating, I'm going to go ahead and select the drop down and make assembly from part / assembly. It's going to automatically start this begin assembly option here and highlight that part that I had open. You can see that I can, if I select it, I can drop it anywhere in the graphics area I'd like, but if I just hit the OK button, it will automatically insert the part at the assembly origin. So you can see I just selected my assembly origin down here, which is that little blue dot there. And if I expand the part and select its origin, you can see it's in the same place. So that's exactly what I'd like. We have a top level assembly here with the assembly icon, and then a component icon here with the part icon, showing you that this is the first part in this assembly. And there's an F letting us know that it is fixed. I can't move it around. And when I try to move it and drag it, you get a little pop up there telling me you can't do it. All right, so let's start adding new parts to this. The first thing I think I want to do is create what's called the vice dog. It is that little piece of steel that's in the vice that sticks up right here. So I'm going to use the existing geometry in that part to model that new vice dog. So I'm going to go up to insert components here, and instead of inserting a component that exists, I'm going to do insert new part. Okay. Now the first thing SOLIDWORKS wants us to do is define a face to begin sketching on. This is going to be that first reference part. Think of it as like the top, front, or side default plane of an original part or of a part by itself. So I'll select this face. And once I do, SOLIDWORKS enters edit part mode, which basically allows me to work on this new part right here, just as if I was in the part environment. And I can tell that I'm in edit part mode within an assembly because all the other components that aren't being edited go transparent. So right now there's no geometry for our new part. That's why all we see is just this one transparent part or component. I'm going to go ahead and look normal to this hole, and I'm just going to control select the inside edges there. And I'm already in sketch mode. It automatically started sketch when I selected that face. And I'm just going to offset those entities. I want them to go inside. And and I don't want them to touch the walls of my vice jaw. So I'm just going to offset them by a 64th of an inch. Click OK. And you can see now I've got my part profile there. It should be showing black lines around this, but sometimes graphics can be a little funny in SOLIDWORKS, but it's there. So now I'll go into features and extrude that in the other direction by 1.775 inches. All right, and I can see that I've created that vice dog, or at least created the majority of it. I still want to put a tapped hole into it, and I'm going to continue using this vice jaw reference as a reference to create that. So I'll go over to the hole wizard. I'm going to make sure that I've got a 1/4 inch -20 tapped hole selected. And we're going to do blind distances here. 0.25 inches. See, the nominal distances here are what SOLIDWORKS has for that type of fastener. And when you go in and change it, they turn yellow. Just to kind of let you know that, hey, these weren't the original distances built in associated with that fastener, which is okay in our situation. I'm going to go ahead and go to the position and use referencing to position my hole in the center of this radius there. All right, I'm going to click OK. And looks pretty good. OK. All right. So now I have exited the part edit environment. You can go back into it at any time by selecting the component and selecting edit part. Leave by clicking the confirmation corner. And just like I showed you briefly, I can actually right click on this and now open the part in its own window. So this part hasn't even been saved yet, but I can still open it. Isn't showing me my thread features here, so I think I'll go in and try to toggle that. Detailing. Cosmetic Threads will show you a little dotted line around the circumference of the hole, and shaded Cosmetic Threads gives you that actual threaded look, if that's what you're looking for. I might have the threads defined a little differently here. You see here, got that Cosmetic Thread selected. Got all the values how I'd like, and there we go. Now they're showing. So you can actually hold down Control and Tab through open documents. Let's go ahead and save this. We'll go back to our assembly. And we're going to continue adding some more stuff to this assembly. Next, we're going to do some Toolbox components, which you can access from the design library on the right. Select the Toolbox and click Add in Now if you have to. I'm going to go into ANSI inch options here, and we're going to go ahead and drag a washer over first. So I'm going to go ahead and drag this, and you can kind of see how as I drag it, it snaps around a different geometry. So what I want to associate this washer with is the hole that I just made in my vice dog. So I'm going to drag and drop it directly on the inside of that whole thread right there. Once I do, it places an instance of it, and that's the size I'm looking for. So I'll just say OK in the check mark. Click the X to stop placing individual instances. And you can see that I've got a washer in there that is coincident to that vice dog hole. And if I look in the mates folder that is created automatically by that, you can see that it automatically created a coincident mate there for me. We'll learn more about these mates here as we continue. Right? But what I want is for this washer to be flush against this face. So let's add another mate. This is going to be one of the quickest ways to create mates are to select the things that you want touching, things that you want coincident, the geometry that will be making up the mate. Control select it. So in this case, I'm going to select this face. And while holding control, select this face, because those are the faces I want to be touching coincident to each other. And then when I let go of control, I get a pop-up here with different mates that SOLIDWORKS thinks I can apply based on those selections. Coincident is the first one, so I'll just select it, and it automatically created that coincident mate without me even having to go into the mate command here, which we'll look at here in a second. So now I've got my washer in place. I want to create a thumb screw there so I can untighten, pull it up, tighten it up, make this thing work the way it's supposed to. I'm going to go back into Toolbox for that, and we're going to find the thumb screw option. We've got bolts and screws, thumb screws, and I think I'm just going to grab a regular size screw and pop it over here. You can see that it automatically sizes and places correctly if I grab that little edge of the washer there to drop it onto. As soon as I let go of the mouse key, I can continue to size the depth of this part by changing the handle there. And in this case, that's as short as can be, which is fine for us. I'll go ahead and click OK. Click the X, we only want the one. And now, because I dropped that on an edge, it not only created a concentric mate automatically, but it created the tangent mate for me. So we've got concentric, I'm sorry, not tangent, but the coincident mate. So automatically created these two mates to place it just how I wanted. So SOLIDWORKS is pretty intelligent in that manner. Now, you can see that this thumb screw is spinning. And let's say I didn't want my concentric mate to have that spin. All I got to do is right-click on an existing concentric mate and select Lock Rotation. When I do, you can see that the center of that icon fills out. So that's telling me that at a quick glance that that is locked, and I can no longer rotate it on its axis. So that's a good way to change concentric mates around and make them behave how you might want. Say you're putting a fastener in there or something like that, and you certainly don't want it to be spinning around. You can lock that concentric mate. Just unlock that again. Back. All right, so we're pretty much where I want to be with this little bit of the assembly, except lastly, I can't move my bench dog up and down, because when I created it in the context of the assembly, it created this in place mate right here. And that's basically to keep it in place so the references on it don't change. If I go in here and suppress this mate, just like you can do any other feature, it's going to get rid of those mate references. Now, I need to reapply mates to get this thing to stay within the confines of this slot, or else next time I rebuild this model, it's going to remodel this part based on its new position. So we don't want to do that. That's going to start breaking stuff. So let's go ahead and build some new mates in here. All right. Now, since this is kind of hovering in the center of this recess here for it, the walls don't actually touch. I'm going to go ahead and jump into the mate command, and we're going to use an advanced mate, the width mate. I'm going to deselect that face I have selected there. And basically with the width mate, it allows you to define a tab that fits within a width selection. So the tab is what the smaller constraints that fit within the larger constraints, if you think about it like that. So if I select my tab option here, and then define these two parallel faces as the tab, and then go into the width selection and define these two parallel faces as the width, you can see that it automatically pops those two faces in the middle, centered between the width selection. If I were to select free, for example, we'll go ahead and click OK. You can see that I can only go just a little bit back and forth there. And we don't want that. So I'm going to go ahead and just reselect my mate down there so I can edit it again and centered. All right. I'll click OK, but keep the mate dialog open so I can apply another set of mates. As you saw, this guy is still free to move in the other direction there, so this direction. So we'll just do one more set of mates with mate. I'm going to go into the tab selection, just like I did for the other ones. Let's see, a little bit of that face is still showing. There we are. All right. Go ahead and rebuild. Looks like we've got some mate errors already. So what's happened there is I've changed the position of this dog so that it's messing with these other concentric mates right here. So I can just go in and redefine those. So this is missing a face now, so it's somehow became unconnected to that to the face that I needed. So I'll just delete that and see if I can find that face. Wondering what happened to my, maybe my part got switched around here. So let's hover this part in. I'm going to hover my main fixed jaw or jaw assembly here, and just with hovered with my mouse, I'm going to hit the tab key. You can see that that hides it. And for some reason, looks like my the hole in my vice dog disappeared, which is giving me the problem. So go in and edit the part. Try to redefine my hole. It thinks it's down here because of the way it was built in context of the assembly. So what I'm going to do for now is re-show my part. So if I hover where the part was with my mouse and then hit Shift and Tab, it'll come back. And I'm just going to go back and unsuppress my in-place mate to keep all those working correctly. Now, if I go back and suppress it again, everything is resolved and it's moving almost as planned. But you can see that we don't want it to actually come out, in and out like that all the way. So we'll create one more mate just to help make sure that that behaves correctly. We're going to use a advanced distance mate. So the advanced distance mate allows you to set a maximum distance to move from selected features and a minimum. So we'll select that face, and that face is our two features. we're going to say a minimum of 0 inches and a maximum of 1 inch actually is fine. And I will click OK. So now that's going to allow this face to move a minimum of 0 inches and then a maximum of 1 inch away, giving us almost, go back and do our in Placemate one last time. Let's press that, put everything back, and then I can now everything works just as expected. So that's our first assembly. So I'm going to use this assembly we created. Go ahead and save it. We'll save it as a new name, Assembly 1. Don't want to save that in my thread profiles. We'll just save it up to the desktop. And again, we'll save all that internally. Okay. Yes, yes. And then I'm going to just keep that in Placemate going for now so all my mate references don't act funny. All right. So one last save. Now I'm going to create the rest of the assembly using this assembly, just as we did before. So actually, I'm not going to do that because I want the first part in my new assembly to be the fixed part, and it won't be this part. So we have our assembly here, which I'm going to use as a subassembly in the next part of our assembly. And go ahead and start a new assembly by double-clicking the assembly icon from new. And I am going to browse to the place where all those are held. And I'm going to choose the fixed jaw. So the woodworking vise fixed jaw. We haven't created this part yet, but I'm going to step through it just to show you how it was created. There's nothing on this part that we haven't shown you how to do yet. So I'm just going to click OK to place it at the assembly's origin. And I'll go ahead and click it to open it in its own window as a part, just to show you how it was made real quick. Nothing too fancy here as far as complexity of features. You can see I created a profile to make an initial extrusion. Then I created a reference plane in line with the center of these holes. I used that reference plane to create that extrusion. And I started building upon that extrusion with other extrusions, using sketching and symmetry to build. Then I started cutting away using various techniques and profiles. Added a little bit more down there at the bottom, some tapped holes, some more cuts, and eventually fillets and the I get it down there. So let me go ahead and show you how to create that text real quick, just so you understand how it was created. I can edit the feature and look normal to it. You can see that basically it's just a boss extrude, and the text was created using the text tool here, and I get it. So you just create an edge or a line, or in this case, I used a center line. I just sketch that, and then once you select the text tool, you can select that line to begin typing text on. So that's how that worked. It's pretty straightforward. It got me the I get it boss. All right. So this is my fixed jaw assembly. This is the part that's going to be fixed in this next assembly. Go tab over to the assembly I just created a second ago. And now let's start adding parts to this. This would be the part that would be mounted to a bench top or whatever. So it is correct for it to be fixed. Let's go ahead and just start adding additional components to this. I'm going to go ahead and click the Insert Components option up here. And we're going to be using existing components. So I'll go Browse. And the first thing I want to insert is the vise guide bar. This is not something we've modeled yet, but again, it's a very simple thing. I'll show you how to do it here shortly. As I'm placing instances, I can use this orientation box down here to help me kind of roughly place the parts how I'd like. I want to have these oriented in this way, so I'll just hit Y a few times and then insert one more example or instance of that guide bar. There. Now we've got two. All right, and I'm just going to Control Select concentric faces to start building my mates. Concentric. All right, and you can see that these are now moving in and out. These guys will be tied together, so I'm going to go ahead and do another mate, mating these two in faces together, coincident. So now that they're coincident, you can see if I move one, the other one moves. So let's real quick just open that part so I can show you how it was built. Just a simple Revolve feature. And if I edit the sketch, you can see that I just created a thin profile and used the center line to define the diameter of that. Go back to our assembly and continue adding components. I think the next thing I want to add is the bracket at the end here. So once again, into Insert Components. If it's not an open document, it won't be in here. Our bracket is not currently open. So I found it right here. Just double click to bring it in. It's already kind of oriented the way I'd like. Click to place it, and then begin, again, creating quick mates. Concentric. I can move that away just to make sure that I have my selectable surfaces. And we're going to go ahead and make that face and this face coincident as well. So this is starting to build just like you would build it in real life. I try to assemble assemblies just how I would in real life. So that's where we're at here. Let's go ahead and put in our threaded bar. That's another thing. We'll take a look at how it was created. Go ahead and browse for the vise screw. Just get this oriented roughly the way I'd like. Click to place it. And I can go ahead and select pretty much any cylindrical surfaces to get my initial mates going. All right. So obviously this won't be threading or moving in and out like that. So we need to start solidifying things. I'm going to just move this here to where this is just stepping out of the other side. So I can come in and add another toolbox component and finish up my mates. The next thing I want to do is add a retaining ring. It's going to be an external retaining ring, just a simple one here. And I can just drag that onto my part, and it should automatically place it and size it correctly. And it looks like It's almost the right size. It's sizing it to that diameter. I want to just go in here and make it a little bit bigger so it is the correct diameter down to this space. It is. Click OK. Just want the one instance. And you can see that that created some automatic mates for me. Now I can use that face and this face. Oops, face, not edge. To create that last mate, holding all those things in place. Just like it would in real life. All right, let's take a look at how this bar was created. The vice screw. All right, so you can see that basically I used a thread feature to create that thread. Now, otherwise, it's a pretty simple revolved part. You can see if I show you the sketch, just simple profile there, revolved around to create the base of the screw, and then I put a hole through the end of it. And now, when it's time to create the thread feature, you can go into Features, and under the Whole Wizard dropdown, you've got thread, or you can type it in the search commands field up here. Now the thread command allows you to pick from lots of different profiles. This vice screw profile is a custom profile I've added and created in here, and I'll show you how that's done. But let's just go with, say, a standard inch die with different configurations here that lets you choose from. Thing it wants me to start off with is a cylindrical edge to define the starting point. And then you can do either blind, revolutions, or up to selection, which is what I'm going to use in this point to define the in condition. And I'm going to select this opposite edge to define the in condition. And this is a kind of system heavy type feature. So depending on how strong or powerful your computer is, it can take a little bit of time to complete these the preview for this. So expected to just have to sit here for a second till this previews. And it'll give you an idea of what that looks like. Then I'll go ahead and show you how I created the custom tap profile. It wasn't giving me this long of a wait yesterday, so I apologize for that. If it doesn't work here pretty soon, I will go ahead and just restart the thing. If we do end up running a little past an hour today, guys, we will have this this entire session recorded and posted up for you to review. You can kind of see there now. It's done a ton of revolves. That's why it took so long to preview. But short end of it is that this is not the profile that I want for this screw. In fact, none of these profiles that exist here are a profile that I think would be suitable for this screw. You can see here that preview is a little bit better. It's not exactly what I'm looking for. In that case, I'm going to have to create my own thread profile. So I'll go ahead and exit thread, and I'll just show you how I did that. I'm going to just reapply the thread feature there. You can see that this is basically a box profile. If you look at the thread profile that I have here, normally, this is the sketch right here. Pretty simple sketch. This box is what defines the cut shape and depth. So this 0.04 is how deep it cuts. This 1/64th here is how wide the cut is. And then this center line, which is also called the pitch, defines how far away each cut is. It defines this pitch for this helix. So let's go ahead and show you how that would be created. I can go, I'm going to go ahead and minimize some windows here just to show you the SOLIDWORKS screen. So I can drop something here. Going to go SOLIDWORKS, come back, there we are. And go into my files. This is where here I'll show you the screen. I have all of the thread profiles here, which are located under Program Data, SOLIDWORKS, SOLIDWORKS 21, and Thread Profiles in my case. So I'm going to drag this into SOLIDWORKS just to open it and show you. It's just a simple sketch profile with the regular old dimensions and callouts, just like in any other sketch. To make this a library profile part, all you have to do is select the sketch that you want to create a profile of from. This is an important step. This must be selected in the feature manager over here for this to work. And with the sketch selected, go to Save As and choose Library Feature Part. And once you do that, it will save it in the directory of choice. So you can use it then as your own custom profile. You could make this anything, you know, a triangle if you wanted, a circle. As long as it had this basic geometry that I've defined here, it will SOLIDWORKS will recognize it as a thread profile, and you will be able to use it as a thread profile. So I'm going to go ahead and close that, and we'll go back into our part there. And if you're unclear where your thread profiles are located, you can go into System Options and look at File Locations and select Thread Profiles, and it'll tell you exactly where they are. So you can save your own custom library profiles to this location, and they will be selectable within the thread feature within the dropdown when you're creating your threads. So there we go. That's how the bar was created. I'm going to go back to my fixed jaw and just show you that I basically did the same thing for the hole here. I just used that same thread feature and just inverted the thread profile so it cut away material how I'd like. So now those threads will match up. Let's go back to our main assembly. There we are. We'll continue working away on this. Now we need to add that other assembly we created, and we're going to insert it as a sub-assembly. So if I go to Insert Components, we see that we have the assembly 1 up there that we made, which was our moving jaw and the other dog component. I'll just click once to place it randomly, and then just like the other components, begin to mate it to the assembly. And drag components out of the way to see where I need to add mates and make the geometry selectable. All right, so last thing I want to do here is fix these guide rods to the face here. And I can do that by making those two selected edges coincident. In actuality, these guide rods would be press fit into this to where they would not move at all. So that's basically making this all one solidified part. All right, so let's go ahead and build in the mechanics to get this screw turning. You might have guessed it, we're going to use a screw mate to do so. If I go in here and look at my geometry, we can kind of see that we've got a place where we want that to start. Doesn't really matter, but if you want it to look good, sometimes just get it in a good starting position. And I'm going to, again, hover this screw component. First of all, I'm going to go into my mechanical mates, deselect the faces, select screw here. We're going to define the screw mate using revolutions per inch. We'll start off with 1 revolution per inch. And I'm just going to hover this and hit tab. Guess it won't let me do that within the active command, so I can do my feature flyout and right click and choose hide. So now I can see the geometry in here I want to select. I'm just going to select this cylindrical face. I'll go back and show the screw and select a cylindrical face for it. And you can see that I'm previewed with the rotation here, a forward rotation. I could reverse it if I want, but that's the way I'd like to do it, is forward rotation. So we know that it's going to preview correctly. Click OK. And now when I move this part, you can see that the screw is spinning, just like it would if the vise was working correctly. We'll come and modify that here in a little bit, but let's go ahead and finish it off by adding the handle to our vise. So again, we're going to browse, this time for the hub. I'll make sure it's roughly oriented correctly before I place an instance of it. A lot of concentric mates here in this assembly, so pretty easy to get things to line up. I'm just going to line up those 2 bores just like they would if they were held by a fastener. And so now that fastens the hub into place. Let's go ahead and add in a screw. So again, from our toolbox, we're going to go into, I think, machine screws here. And I am just going to add a Fillets head screw by dragging it and dropping it onto that face. I can adjust its length. I think maybe a little bit longer. There we are. And then click OK to place it. And we just want the 1 instance. And there we have it. Screws in place. I will go ahead and ensure that that concentric mate that was created is locked for this option, as screws don't want to spin once they have been fastened completely. All right, we're getting close to the end. We'll go ahead and insert another component. This time picking the handle. Gotta make sure I pick the right part. Strong. That's the handle in, and there's the handle. Okay. So I'll click once to place it. And again, for the concentric mate. I don't think I want to lock the rotation, so I'll uncheck that option. And then we can finish up the last component, which is the end. Click to place it. And this time, I'm going to select this end edge and this end edge and choose coincident to both make them centered and attached to each other. All right, you can see that that still spins, even though it's got a coincident relationship, which is, it's okay in this case. But I don't want this bar to be moving past the extents there. So guess which mate we're going to apply to keep that acting right? Our good old friend, the width mate. So I will use these two faces for my tab selection. And when I try to select these edges, it's not letting me do it. It wants a face selection, a parallel face selection with the tab. Well, in this case, I knew that that would be a problem. So I've actually created reference planes, you can see right here, to use as the reference for both my woodworking vise handle and the handle end. I can choose to keep that centered if I want, or free. And when it's set to free, you can see that it's a little jumpy in this case, but it can move up and down freely within there. To keep things less jumpy, we'll put it to centered, click OK, and you can see that now the vise behaves almost exactly how it would. The last thing we're noticing is that this screw profile should appear as it's standing still if it was set to the right setting. But instead you see the profile moving through the part there. So we need to adjust our mate, our screw mate, to correctly represent that threading pitch. So I'll go into our screw mate, edit the feature, and right now we have it set to 1 revolution per inch. I know that the pitch on this that I created was an 1/8 inch. So if I change it to 8 revolutions per inch and then click OK, that should give me the exact pitch I'm looking for. And when I move the part, you can see that now the profile behaves exactly as it would. It's not moving in and out of the part. It's threading through the part. I can also drag on the hub to incrementally move the vise just like it would in real life. So now I can test out my behavior of this vise to see if it works, all with mates in 3D space without actually having to build a single part if needed. Show you a couple more things before we finish up today. As you can see, I can't move my dog assembly here. That's because by default, when you insert a sub-assembly into an assembly, you can see that this is a sub-assembly because it's got an assembly icon here. It's created as a fixed sub-assembly. If I wanted to, or rigid sub-assembly, I'm sorry. Rigid means the parts within the sub-assembly cannot be moved. If I wanted to move those parts within the sub-assembly, I'd select it and select this option up here, make sub-assembly flexible. And once I do that, do I still have that mate, that in place mate going? All I gotta do is edit my assembly, and I can suppress that mate like we did before. And now you can see I can move that part. I can go back, choose to make it rigid again, and when I do, it's back to how it was. All right, last thing I'm going to do is create a sub-assembly on the fly here. So I've got these parts that make up this handle and hub, and I would rather them just be their own standalone assembly instead of all individual parts. So As you can imagine, pretty simple to do. All I need to do is select the parts that I want to create my subassembly, control select them, right click, and choose Form New Subassembly. And once I do, you can see a new subassembly is automatically created. And if I wanted to open that assembly on its own now, it exists by itself. Conversely, if I wanted to take a subassembly that existed and dissolve it to just one top level assembly, I can select Dissolve Subassembly from the right click menu. I could do the same thing for the existing subassembly we already made. Dissolve Subassembly. It'll ask you to do some different mates and other prompts sometimes, but it's pretty straightforward to get through that type of stuff. So I will go ahead and go back to our assembly here. I just cancel it out of that subassembly dissolve. And we still have that original subassembly. So I think that about covers it for our session from advanced part modeling to assembly making. Highlights are that when you create assemblies, use in-context modeling as much as possible to help save you time. For example, that vice dog was created pretty quickly and easily without having to refer to any dimensions. And try to assemble your components just as you would in real life and apply the mates as those components would relate to each other in real life, so you can test it as accurately as possible. So with that being said, I just want to say thank you for coming, checking out our assembly session today, and we will see you for the next one. One last thing, I believe in the text thread for this meeting, in the chat for this meeting, we have posted the finished zip file for this vice model. If you guys want to download that, all these parts are in there and you can play with it yourself. You can modify them, look at them, see how they were made a little bit closer if you want to learn a little bit from that as well. So thanks again,